Discussed in class how it's possible to make measurements to determine the energy to form point defects. And anything that has an Arrhenius relationship, we can make a measurement. So let's say we have some spectral means or some method to measure the number of something, in this case, say vacancies, at a given temperature, or let's say the fraction of vacancies at a given temperature. So we have some V per T. Now we know that this is an Arrhenius relationship, so we know it's going to be V N X negative E F over KT. It's going to have this functional form, and it's going to look something like this. Right? So as we increase temperature, we have this exponential increase in the density of vacancies or whatever we're looking at. And what I said in class is that if we instead plot the natural log of the density of vacancies versus 1 over the temperature. So now high temperatures over here and low temperatures over here. You look at a straight line. So these are, say, our measurements. We'll get some straight line. And with that straight line, the slope is equal to negative EF over the Boltzmann constant. And this intercept is the natural log of n. So where does that come from? This comes just from a little bit of mathematical manipulation. So, say, we'll start out just with our Arrhenius relationship. NB is equal to N X negative E F over KT. Now, if we can operate on both sides the same, so we'll take the natural log of both sides. I wish I could explain what's happening with the focus on my camera. So I'm going to take the natural log of both sides. That's going to give me the natural log of NB is equal to the natural log of N times X negative EF over KT. The natural log of a product, let's say A times B is equal to the natural log of A plus the natural log of B, which means we can split this up to be the natural log of N plus the natural log of X negative EF over KT. If you're taking the natural log of an exponent, then it goes away. So that gives us the natural log of N is equal to natural log of N plus negative EF over K 1 over T. And we'll rearrange that to be the natural log of NB is equal to negative EF over K 1 over T plus the natural log of N. And this has the same functional form as y is equal to mx plus b. All right, just the equation of a line. So if we plot y as the natural log of the number of vacancies, or the density of vacancies that we measure, and we plot that versus the x, which is 1 over the temperature, then we naturally get from this a slope, which gives us the energy to form the vacancy divided by the Boltzmann constant, or negative of that, I should say. And then we get an intercept, b, which is the natural log of n. And this is where plotting an Arrhenius relationship like this works. And I should spell that out for you. If you want to go read about this, it's called Arrhenius. So this is an Arrhenius relationship.